Hello everyone. In this lecture I am going to teach you how to solve the friction of connected bodies. Before going to the problem, let me teach you the concept first. Here I have considered three different examples of connected bodies. In the first case, two blocks are placed in two inclined planes. These two blocks are connected with a spring and the string is passing through a frictionless pulley. If the pulley is frictionless, then the tension acting on the string throughout the length is equal. That is, TA is equal to TB. In the second example, two blocks are connected with the help of a string. So here the TA is the tension acting on block A and TB is the tension acting on block B. These two bodies are connected with the help of a string, so the tension throughout the string is equal to same, that is TA is equal to TB. Then the third case, two blocks are connected with the help of a string and this string is passing over a pulley. Now the TA is the tension acting on A and TB is the tension acting on B. Since the pulley is frictionless, the TA is equal to TB. So the first important thing about the connected bodies, whether the pulley is frictionless or friction pulley. In most of the problems the pulley will be a frictionless pulley, so the TA is equal to TB. The second thing is the direction of motion. So here, if the body B is moving towards down, then the body A will move in the upwards direction. If the block A is trying to move in the downwards direction, then the block B will be moving in the upwards direction, because the direction of motion is going to affect your direction of friction. And here a force P is acting in the positive x direction. Since the force P is acting in the positive x direction, this body block B will move in the positive x direction. So if the block B is trying to move in the positive x direction, then the block A will move in the upwards direction. Now the problem. Two blocks of weight 800 Newton and 550 Newton are connected as shown in figure. What will be the required force P to start the movement? The pulley is smooth, so this is very important. The pulley is smooth and the coefficient of friction between the other contact surfaces are 0.23. So the mu is given as 0.23. So this is the given drawing. The two blocks are connected with a string and the string is passing through a frictionless pulley. Since the pulley is frictionless, then the tension acting here is equal to the tension acting on the next block. So let us consider this as block A and block B. So first we will start from the free body diagram. So we will start from the block A. The weight is acting in the downwards direction, 800 Newton, and we know that the angle between horizontal plane and the inclined plane is same as the angle between the weight and the y-axis. So this is 30 degree. So now let us resolve this into two components. One is 800 cos 30 degree and another one is 800 sin 30 degree. Then a tension is acting here, write it as T. Because of the friction between these two contact surfaces, there will be a normal reaction and the normal reaction force will be acting in the perpendicular direction. Let us consider this contact surface as 1, so we can write it as Rn1. Now the load is acting towards right, so the block B will try to move in the right direction. So if the block B is trying to move in the right direction, then block A will be moving in the upwards direction. So the friction force will be acting in the opposite direction of motion. It is Fs1. Okay, then consider the block B. the weight is acting in the downwards direction. So the free body diagram for block B is very simple since the block is acting in a horizontal plane. Then the T is acting in the left hand side direction. The load P is acting with a inclination 60 degree. So let us resolve this into two components. One is P cos 60 and the another one is P sin 60. Because of the friction between these two contact surfaces, there will be a normal reaction force Rn2. So this is our contact surface 2. Then the body is moving towards right side, so the friction force will be acting towards left hand side. This is Fs2. Okay, so now we can write the equilibrium equation. We'll start from the block A. So consider block A first. The summation of vertical forces is equal to 0. In the block A, the Rn1 is acting in the upward direction. So it is Rn1 and 800 cos 30 is acting in the negative direction. So minus 800 cos 30 degree is equal to 0. Now the Rn1 is equal to 800 cos 30 degree, that is equal to 693 Newton. Then the next is summation of horizontal forces is equal to 0. So here the T is acting in the positive direction, so it is T, and the 800 sin 30 is acting in the negative direction, so minus 800 sin 30 degree, and the friction force Fs1 is acting in the negative direction, that is left side, so it is minus Fs1 is equal to 0. And we know that this Fs1 is equal to mu into Rn1. In the problem, the mu value is given, that is mu is equal to 0.23, and we have already calculated the value for Rn1. So we can substitute the mu and Rn1 in this equation and we can calculate the value of T. So the T is equal to 559 Newton. Okay. Now consider the block B. Summation of vertical forces is equal to 0. Okay. So here the 550 Newton is acting in the downwards direction, so it is negative, minus 550. Then Rn2 is acting in the upward direction, so it is positive, so plus Rn2, and P sin 60 is also acting in the upward direction, so it is plus P sin 60 is equal to 0. So now bring this 550 Newton to the right side. Rn2 plus P sin 60 degree is equal to 550. Keep this as equation number 1. Now let us write the summation of horizontal forces is equal to 0. The T is acting in the left side direction, so it is negative minus T, and P cos 60 is acting in the positive direction, so plus P cos 60, and the Fs2 is acting in the negative direction, so minus Fs2 is equal to 0. And we know that the Fs2 is equal to mu into Rn2. We know the value for mu, that is 0.23 into Rn2. So substitute it here. And we have calculated the value for T, that is 559 Newton. Substitute the value of T also. We will get 0.23 Rn2 plus P cos 60 degree is equal to, bring the T to the right hand side, it is 559 Newton. This is equation number 2. Now by solving the equation 1 and 2, we can get the value for P. So the value for P is 980. Now, okay. Now the important point about the connected bodies problem is, first, the tension throughout the string is equal. Then the second thing is the direction of motion. So in this problem, the load is acting in the right side direction. So the body B will move in the right hand side direction. So this will make the body A to move in the upwards direction. Okay, thank you.